So we have graphed already, right? We graphed our parent functions, transformed our parent functions on a graph. We've graphed piecewise functions, but we are not graphing polynomials. What are we doing with them? Sketching them. So that's a little bit different. When we were graphing them, we graphed all the specific points we could find, and if we wanted to find more, we could have. We could have found every single point on the function. I mean, I guess not literally because there was an infinite amount, but we could have plotted a whole lot more and actually got a really accurate graph. So we're sketching these polynomials because we're not going to be able to find all of the specifics that we need to get a super accurate graph, because we would need the calculus behind how to find the maximums and minimums. We're not in calculus, so we're not doing that, all right? And so it's not going to be as exact. And you'll see there's some things that have to be very specific and then other things that we just kind of guesstimate on. And I'll show you the differences here. All right, so we're going to start down here first at the bottom, and then we'll go back up to the top. And so we're talking about in behavior again, which we've talked about a lot. It was on both pages yesterday. And we're going to actually talk about some middle behavior today as well. So if I have an even degree, if I give you 4x to the 4th minus 3x squared plus 2, you have no idea what that graph actually looks like. I don't expect you to at this point, but you would know that the highest exponent is even and that the end behavior would model a quadratic, right? So don't know what's going on in the middle yet, but if I have an even degree and a positive leading coefficient, then my end behavior is up, up. And we're more worried about the arrows today with our sketching than we are with the words, but what this means and what this tells me is that as x approaches infinity, f of x approaches infinity, right? And as x approaches negative infinity, f of x approaches infinity as well, okay? Then if it's still an even degree, but I have a negative leading coefficient, then just like in all the other graphs, all that does is reflect it in the x-axis. So my end behavior goes from up, up to down, down, and both of these change to negative infinity. Okay. Then we have an odd degree. Again, if I gave you a polynomial, you wouldn't necessarily know what the graph looks like, but you would know that the end behavior models a cubic. So if it's a positive leading coefficient, my end behavior is down, up, which into words translates as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. When I have that negative leading coefficient, again, we just reflect in the x-axis, so my end behavior becomes up, down, and these switch places as well, so this becomes negative infinity, and this becomes infinity. Everybody good with that? You should be able to do that in your sleep by now, right? The words, at least. I know the whole arrow thing is kind of new, but just know how that they all relate together and we're good. Okay. So let's go back up to the top, and I'm going to talk you through the steps of how to sketch them, and then we'll look at them. So some of the steps may not make 100% sense to you until we actually do it. That's okay. So the first thing we do is we find the X-intercepts, which we totally know how to do, whether it's factored or unfactored, but all we're really doing right now is the already factored form, which makes it even easier. We also need to find the Y-intercept. It says that it's the constant when in general form. So if I give you 3x squared minus 2x plus 7, your Y-intercept is 7. But these are going to be in a factored form, so it takes a little bit of math, but not much, and it's super easy, so don't mess it up, and you know how to do it. So then 3 says, notice if the polynomial has an even or odd degree, right? What is the degree even or odd? 3, 4, and 5 kind of all go together. 5 we have to notice, or I'm sorry, in 4 we need to notice the sign of the leading coefficient. And then with that we determine the end behavior of the polynomial. So again, all 3 of these kind of go together here. So that if this was, we end up with a positive leading coefficient, my end behavior is either up, up, or down, up, depending on whether or not it's even or odd. And then if it's negative, it's either down, down, or up, down. Again, depending on if it's even or odd, right? That's a big part of what we're trying to do here. Then we have to notice if there are factors with a degree higher than 1. Because then things happen when that is the case. If I have an even power of a factor gives a relative min or max on the x-axis. So if I have like x minus 3 squared, the factor is that x minus 3. That squared is the exponent on the factor. I don't care what the whole degree is of the whole thing. It's just the exponent on the factor has an even exponent. That means I'm going to have a maximum or a minimum on my x-axis. So it could look something like this. Okay, where right here, this is a relative minimum, and it's on the x-axis. It just hits the x-axis and goes back the other way. It could come up from underneath also. So, yes, it's a relative max or a min, but this causes what we will call a bounce, because graphically, that's exactly what you're doing when you're sketching it. You just bounce off the axis and go back the other way. In technical math terms, that is where it is tangent to the x-axis. It doesn't pass through, but it's tangent. If I have an odd power greater than 1, because 1 is odd number, so 1 doesn't count, that locates a point of inflection on the x-axis. So that would look something like this. Where this right here would be my point of inflection, which as far as graphically what it's looking like and what we're doing is that's where your wiggle is. Okay, so we have a wiggle and a bounce, which is a point of inflection and tangency. But when you're graphing, that's what happens. It just wiggles right there or it bounces off the axis. Okay? And then we draw a continuous curve, because remember there's no discontinuity. I shouldn't have to pick up my pencil. You might want to just to help you with the curve, but like you could do it all in one stroke there. Observing proper behavior at each 0, Y-intercept, and end behavior. Okay, so there's like a long list of things to do. It's really not that big of a deal. You just got to make sure you know all of that, because if you're missing any pieces, you're not going to be able to get through your whole graph. Okay? Any questions at this point? All right, let's do one so it'll make this make more sense. All right, so looking at number 1. Now on here, there are blanks for you to fill in because we need this stuff to be able to do our sketch. Your assignment today is on Delta Math, and you're asked to sketch it. You're asked to do the same thing, but it doesn't give you these blanks, but you need to have something next to you because you need to write that stuff down because those are the things you need to actually do it, if that makes any sense. You're going to have a digital assignment that goes with this. You need to practice at least a little bit tonight. If you don't get the whole assignment done, fine. You don't have to, but at least 1 or 2 so you've practiced a little bit, because tomorrow I'm going to give you a piece of paper and then you're going to do it on your own on paper, kind of like we're doing on the notes, okay? And then I'll be in here to kind of assist you with it. All right, so the first thing I do is I look at this. I've got how many factors here? 3. There's 3 factors, right? So that your factors are, when you factor, that's what you get as factors. I'm not going to multiply it all together, but if I did, what would the degree be? Yeah, x to the third, because I'd have x times x times x, right? So it would be a 3rd degree, which is a cubic. All I really need that number for, that number helps me with my end behavior. It's odd, so the ends are opposite, and it's either down, up, or up, down. Which one is it? Down, up, because it's positive. So it looks like the cubic. And well, it is a cubic, but when we graph it, it won't look like what you think a cubic looks like. All right, then my x-intercepts, and it says intercepts, so they need to be in ordered pairs. If it said zeros, I could have a list. But that should be super easy once it's factored. This one gives me -1, 0, then 3, 0, then negative 4, 0. None of my factors have an exponent greater than 1, so I don't have any bounces or wiggles on this one. I need to find my y-intercept. That's easy. That's when x is 0. So that's just going to give me 1 times negative 3 times 4, which is negative 12. So I'm at 0, negative 12. Okay. On my y-axis, let's start with the x-axis. We're going to put some hash marks on here, but we are not getting out a ruler and making it perfect. It doesn't need to be perfect. This is a sketch. I mean, you need to make an honest effort to make it look semi-decent. But I need to figure out basically how many hash marks I need. I go out to the negative 4. I only go 4 spaces away on either side, so I could probably just do my best to evenly space and get 5 on there. 1, 2, 3. And again, just kind of do your best to make them evenly spaced. My y-axis, I'm not going to put a bunch of hash marks on there. I only care about one value on there, and that's negative 12. And so I'm just going to say, well, right here, that's where negative 12 is. And that one you have to label with a number because there aren't other hash, like these you can count. You don't have to number them because it's obvious what they are. This one just like, bam, there's a negative 12 down there. So now we are going to plot these points. Negative 1, 0, 3, 0, negative 4, 0, and then this 0, negative 12. Okay. So I have all those points, which are important points. What I don't know, and I know there's going to be curves here, I don't know my maximums and minimums because I'm not capable of finding them at this point, but that's okay. It does. Maybe I don't even care depending on what I'm going to use this for. To sketch in my curve, this is where I use my end behavior so I know where to start. Okay, so I'm going to explain it to you, and then you can watch me do mine, and then you can go do that. It's down, up, so I know I have to start down here. Every x-intercept, you have to pass through the graph. So I'm down here, I'm going to pass through, I come to some maximum somewhere, I come back through here, I have to hit my y-intercept, and then I go back up through that one. You only get to cross the x-axis on x-intercepts. That's what an x-intercept is, right? So when I draw this, it would look something like this. I know my end behavior is down, up, so I'm going to come down here, up, down, hit my y-intercept, back up through here. Okay, I did a not so bad job of actually hitting the middle of the points this time. Last period I was a little bit off. If you're just like a little bit off, you can just make your points a little bit bigger, and then it looks like you hit them and everything is fine. Okay, like, oh, yep, that's what I was trying to do. Okay, because they're not exactly in the right place anyway. This, and when you're done, you double check that your end behavior actually looks like what you said the end behavior should be. Because if I started over here and I ended up pointing down, something's wrong somewhere. Either my end behavior was wrong, or I missed a point, or who knows what. You will, if you do something wrong, you will catch yourself. So don't write this on here because it's wrong, and I'm going to erase it. But let's say that we had messed up on our signs and we got 12. Okay, let's say I got 12, which is not the right answer. And my end behavior, I'm supposed to start down here. So if I start down here and I start drawing, I go up, and then I go down. Well, I can't make it to 12 without crossing through the x-axis again. I don't get to decide to go back up there or anything like that. I can't make it up there. So one of two things, well, a few different things could be wrong. Maybe my y-intercept is wrong, which would be the case here. Or maybe my end behavior was wrong and I was really supposed to start up here and then I could hit the 12. So you kind of got to go back and check. So if it's not working out and you can't flow, something's wrong. Because if it's not wrong, it'll work every time. Okay? Any questions at this point? This y-intercept could be a minimum. We don't know. My minimum didn't have to be on the right of it. It could be to the left of it because we don't know where it is. If your graph on yours, you decided this should go way up and come back down, that's fine because we don't know where it should be anyway. And it's okay. Okay, we good with that? What questions you got? All right, so let's look at number 2. I've got how many factors here? For really 3, and this is a double one, but I mean, yeah, you can kind of talk about it either way. So what is the degree here? 4, because I would get x to the 4th. So this is 4th, it's quartic, but the number's good enough here. It's even, so the ends are the same. It's either up, up, or down, down. What is it? Up, up. Okay. Then my x-intercepts, how many do I have? just 3. Yeah, because this one I don't count twice. So this one gives me 0, 0. This one gives me 2, 0. And this one gives me 6, 0. Okay, so on this one, I do have a factor that has an exponent greater than 1. It's 2. It's even. Okay? If that is even at that point, is that where I bounce or I wiggle? Which one was it? Bounce. Okay? And you can remember, I mean, it could be any even or odd number, but you got a bounce for an even and then a wiggle for an odd, and that looks a little bit more wiggly. Maybe that helps you. I don't know. So then I need to make sure I know which of these points, not just that I bounce. I'm bouncing at this point. So I'm going to make myself a little note that this is where I bounce. Okay. Then I need to find my y-intercept. So y is when x is 0. So this is 0 times negative 2 squared times negative 6. What's that? 0. Did I even need to write all that stuff down? No. Once you see that this is 0, this one has to be 0. So don't try and go do work when you don't need to. Okay. All right. So I'm going out to 6. So I got to make sure I have at least 6 hash marks on here. So 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. And 0, 0 is my y-intercept, so I don't have to do anything on my y-axis here. I've got 3 points I'm going to plot. 0, 0, 2, 0, and 6, 0. My in behavior is up, up. So I have to start up here. This is where I pass through. When I come back up, I'm going to bounce off my x-axis and come back down because this is where my bounce is. So make sure you know where that bounce is so you don't bounce at the wrong spot. So this is what it would look like. I would come up here, come down, go back up, bounce, back down, and back up. And again, I have no clue how far down I really go, but be careful when you bounce that it doesn't look like this because it doesn't come to a point. Remember, these are smooth curves, and it's possible. It's always good to use pencil because it's possible that's what you're trying to do, but like your angle that you came in wasn't enough where you can actually do that. I have to erase on a lot of them, especially on the wiggles. Sometimes when I'm trying to sketch it, it's not coming in just right. So then here's these 3. And again, you double check your in behavior at the end. Okay. So that's how, see, I had 3 x-intercepts here, 3 x-intercepts here, but one's odd, one's even, and they look totally different in behavior and all. Okay. What questions do you have? All right, let's look at number 3. I have 3 factors, but what would the degree be? 5. Do we all understand why it's 5? Anybody need a clarification? Okay. That is odd. Odd means the ends are opposite. Up, down, or down, up? Up, down. Good. If you don't understand why it's up, down, speak now. Okay. Because if it's odd, it models the end behavior of a cubic, right? That's your parent function. And so since it's this is negative, that's why it's flipped. Okay? Well, I missed the first part of your sentence. How do you know? Okay, that's what I missed that. I missed that. How do you know? All right, so do you understand that this is what a cubic looks like, right? The parent function, just plain old x cubed. And so that is down up because that's what those ends are. Make sense? All right, so the reason that one is up down is because this is negative. And when it's negative, that's when it gets reflected. Okay, does that help? Okay, good deal. Don't be afraid to ask because you're probably not the only one thinking something. All right, so my x-intercepts, I have 3. This will be 3, 0, negative 4, 0, negative 1, 0. I have an exponent on my factor greater than 1. That's an odd number, so what happens at the odd numbers? A wiggle, okay, which is your point of inflection. And so that's this one, so I'm going to mark it, and this is where I'm going to wiggle. I'm marking that for myself so I don't forget that that's the one that I do that at, and what do I do? All right, so then we need to find the y-intercept. So you go ahead and find the y-intercept. And let's see if it is a hot mess like it's been all day. Which makes me lose faith in humanity again. So I'm going to take you through my process. Not my process if I was a student, because really I just know the answer because I'm a teacher. No, like when I'm figuring this out, this is what my brain is doing. The first question I ask myself so I don't mess up on a sign is, when all is said and done, is it going to be positive or negative? What's it going to be? Positive. Because this is a negative cubed, which is negative times negative is a positive, right? Now I can forget the sign and I'm not going to mess that up. It's a positive number. Okay, which a lot of people get negative on this. Then negative 3 cubed is 27 times 4. Okay. Yeah, it's 108 because 4 times 20 is 80. 4 times 7 is 28. That's 108. So it's 0, 108. Erase, erase, erase. Okay, we good? All right, so I'm only going out to 4, so I usually like to get like one more on there if I can, but I don't have to, so we'll go to 4 or 5, doesn't matter. I think I'm going to go 5. 1, 2. Sometimes I plan to go to one more and then I run out of room. Just depends. And then I have that 108 up here. So I'm going to plot those points. I have 3, 0, negative 4, 0, negative 1, 0, and 108. I'm going to graph this. I'm wiggling here. This is where my wiggle is. You don't get to wiggle wherever you want. Your wiggle is at that 3, 0. So I'm kind of putting that like a little different little dot there so I can think through that. My end behavior is up, down. So I start up. I go through the x-axis, go back through the x-axis, hit my y-intercept, and I'm going to go through the x-axis again, but when I do, I have to have that point of inflection, that little cubic curve to it right there. And then when you're done, it's like just your end behavior, you think about where you start, you go through your curve, hitting wherever you're supposed to hit, and then hope that you end up on the other end like you wanted, which is what we did want. It's up, down. Okay? So that point of inflection, that's just that middle part of that cubic. Okay? And that sometimes is tricky, I'm not going to lie. That's the one where sometimes I got to pick up my pencil and then back up a little bit because I wasn't coming at it at the right angle to get a curve in there. So don't make it too crazy. It's not a, but that's where we wiggle a little bit. We good? All right. So let's see. Let's go through number 4. So y equals, what's the degree here? 5. This is odd, so what's my end behavior? Down, up. My x-intercepts are negative 3, 0, and 3, 0. And then I have 2 that have 1 greater than 1. So this x plus 3, which is this one, that is odd, so what happens there? Wiggle, that's where we wiggle. This is even, so on this one, that's where we bounce. All right, make sense? Y-intercept, I'm just going to go ahead and give it to you. It is 0 to 43. Good. Okay. Something you should be able to figure out, but I'm going to give it to you. All right, so we go out to negative 3. I'm going to make this 1, 2, 3, 4. 1, 2, 3, 4. 243 is just up here somewhere. Plot this, this, and this. And then I want you to try and sketch that in. Bounce and wiggle in the right spot. Think about your end behavior and where you're going to start. And you can sketch it lightly with your pencil first to make sure like what you're doing makes sense before you actually draw it in, whatever works for you. Did we all make an attempt? So end behavior was down up. So I start down. We pay attention to, let's see. I bounce first and then I wiggle. Because these aren't always in the right order, but that's what's happening. I'm going to bounce and then wiggle. No, I'm going to wiggle and then bounce. I lied. Okay. I wiggle and then bounce. So I come up here, got my point of inflection, come back down there. It should look something like that. Do you understand why it looks sort of like that? And do it like flowy and light at first, so it's not, because some people stress out because they're trying to make it all perfect, and do that first and then, all right. Any questions at all? Remember that your assignment today is on Delta Math. Try at least something, okay? Have a great day.